Good afternoon, my dear learners. In this lesson, we are going to start looking at energy changes. As you can see, our subtopic under chemical reactions. Now, this energy changes is also known as chemical energetics, meaning in this subtopic, we are going to be discussing nothing else but the energy changes that takes place when a chemical reaction is actually taking place. Now, what is important in this lesson, my dear learners? Actually, I want you to understand the terms related to energy changes or chemical energetics. The terms related to chemical energetics. Now, before we go to the terms related to chemical energetics or energy changes, we are going to look at the definition of our subtopic when we say energetics or chemical energetics or energy change. What does it mean to us? Okay, listen, my dear learners. I said energy or energetics, we are talking about the same thing, but we need to understand that when a chemical reaction is taking place, there are energy changes that take place also, because in our chemical reactants or reagents, there are energies that those reagents are going to have. Now, when they are reacting to form a product, there are certain energy changes that takes place. This is what we are going to discuss. Now, to define energetics, we are saying this refers to the energy change. Energy change that catalyzes chemical reactions, meaning every chemical reaction, provided that chemical reaction is taking place, there will be that energy change which is going to be a characteristic of that chemical reaction. Now, under chemical energetics, there are terms we are going to meet, and we are explaining these terms in this place in our introduction so that we can set the ball rolling in such a way that when we meet these terms, we are not going to be getting confused. That's the reason why we are saying terms related to energy changes. Now, in our subtopic chemical energetics, we are going to be using this word or scientific term enthalpy. What does it mean when we say enthalpy? The symbol we are going to be using is capital letter H. Now, what is enthalpy? Definition: this is the total energy in one mole of a substance. So if we have one mole of a substance, for example, one mole of a chemical reactant, we are going to have that energy be known as enthalpy. So when we say, what is the enthalpy of this one mole of calcium carbonate? I don't expect any one of my learners to be facing challenges when I say enthalpy. In this case, I mean enthalpy also means what? Enthalpy means heat. That's the reason why we are saying what is going to be changing is nothing but the heat energy. We understand that heat can be absorbed, heat can also be released from the reacting system. So, meaning there will be that energy change. Therefore, that's the reason why we are also defining this enthalpy as the heat content of the reacting system. The heat content of the reacting system. What do we mean when we say reacting system? This is actually the system or the container in which the reaction is taking place. So our reacting system is the system in which the chemical reaction is taking place. Now, these energy changes will depend on our reactant's nature or physical state. So we are saying the enthalpy depends on the physical state of the compound and varies from compounds to compounds. Yes, because the compounds are not just the same. Even the energy content is going to be different because the nature of the compounds is different. Moving forward. Since there is enthalpy, and we are saying this enthalpy changes when the chemical reaction is taking place, therefore, we need to look at how we can determine the enthalpy change. So we will go now to the enthalpy change. And the symbol to represent the enthalpy change is represented by delta H. That's a symbol. Now, when we just see H, this is enthalpy. When we see something like a triangle and capital letter H, that is the enthalpy change. And the enthalpy change, provided the graph is given to you, we use this formula, where we say the enthalpy change equals the enthalpy of the product minus the enthalpy of the reactant. Very important, my dear learners. And we said enthalpy is the total energy in 1 mole of a substance. Therefore, the units for enthalpy is kilojoules per mole. Now, what is enthalpy change? Enthalpy change is nothing else but the difference in enthalpy of the products and the enthalpy of the reactants. The difference in energy changes or energy content between the products and that of the reactants. So we have looked at 2 terms. We have looked at enthalpy itself and the enthalpy change. Remember the symbols, remember the definitions. Now, in as much as we discuss chemical reactions, I introduced the topic to say there are energy changes that takes place when a chemical reaction is taking place. Meaning, the reaction may be endothermic, the reaction may also be exothermic. So, we are going to meet another term, endothermic reaction. To begin with, when we say endo means something is going inside. Something is entering. To endo is to enter. And the thermic is coming from the word thermo. And the thermo means heat. In this case, we are saying there are chemical reactions that are endothermic. Those are reactions that absorbs heat from the surrounding into their reacting system. Therefore, we are defining an endothermic reaction as the reaction which absorbs heat energy from the surrounding. You need to understand that, my dear learners. Going forward, we have what we call endothermic reaction and endothermic processes. Meaning, not all endothermic reactions or processes produces the new substance. I need to repeat and emphasize. I am saying not all endothermic pathways are catalyzed by chemical reactions. Some endothermic processes are not chemical reactions, they are just processes. What do I mean? We have endothermic reactions and endothermic processes. In a process, we may have the new product or not. But in a chemical reaction, the reactants react to form new products. But in the process, we can have the change, but there is no new substance which is formed. And when we experience that, that indicates only the process and not the chemical reaction. Because in the chemical reaction, the new substance is formed. In this case, I may give an example of the process of photosynthesis in the plants. That process is photochemical. Why? Because light energy is used in plants to split water molecules to form hydrogen and oxygen. Now, since there is bond breaking in that chemical reaction, there is bond breaking, that reaction absorbs energy, and that process qualifies to be called an endothermic reaction. You need to understand that. That's the reason why when we are looking at A, we are having the process of photosynthesis as an example of an endothermic reaction. B, we have photography. In photography, we are being reminded that it is also a photochemical reaction because light is used to split silver halides. When we say silver halides, we are talking about the compounds that are formed from halogens, but they react with silver to form silver salt. That's the reason why we are saying the essential reaction in photography is the reduction of silver ions to metallic silver with the exposure to light energy. This silver salt decomposes into ions, and when they decompose into ions, which will be silver ion and the bromide ion, this silver now is going to be oxidized or reduced. Pardon me, I should have said reduced because we are adding electrons to silver. The addition of electrons to the substance, that is a reduction. Now, since we are having silver with a positive charge, to this we are adding one electron so that we can form silver atom. This silver atom is the new substance because it is different from the actual compound. In the compound we had ions, but in this case we are having what? An atom. So meaning this atom is different from an ion in the compound. Now, this enables us to capture images using a camera. The process is very important. We are giving examples of endothermic reactions. This is what happens. Know this equation. This equation need to be known, but it is not being completed at that stage. You need to continue because we are interested in the formation of silver atom. Now we are saying light is usually absorbed to dissociate silver salts. Another example, dissolving processes. Remember what I emphasized when I was distinguishing a chemical reaction from a process. Here, now we are giving an example which is just a process, dissolving process. Dissolving process is not a chemical reaction. There, we are just going to dissolve the substance. But when we are dissolving that substance, heat is going to be taken into the reacting system. So we don't call that as a chemical reaction, no. When you dissolve ammonium nitrate in water, you are going to form these ions, ammonium ions and nitrate ions. But this substance is just the same as this substance. No new substance has been formed. You have just changed the state from solid to liquid. Only that energy is absorbed when we are dissolving ammonium nitrate. So this is an endothermic process and not an endothermic reaction. Very important. When the examiner say, give an example of an endothermic process, this will be the answer. Dissolving ammonium nitrate, ammonium chloride, all those are examples. Because that is just a process. But when we say chemical reaction, give us examples which are reactions such as the process of photosynthesis, photography. So that's a fact about these endothermic processes. Move forward. You need to understand another important point. Another important point under endothermic reactions is that endothermic reaction is a bond-breaking process. What does it mean when we say bond-breaking process? I am going to give you an example, a practical example, something you understand and something you know. We have three states of matter where we have solid, liquid, and gas. Now, there are processes we call change of state, and some of the change of state are endothermic processes. For example, when we are changing solid to liquid, this is an endothermic process. Melting is an endothermic process. Why? Because we need to supply heat to the solid so that we can melt it. And when we are melting, what will be happening to the solid particles? We are going to be breaking the bond between the particles. When the energy supplied to the solid is enough, the bond or the energy that holds the solid particles in a solid will break. And the arrangement of particles now will be disturbed. Instead of having a regular arrangement of particles in a solid as they are supposed to be, now they are going to be arranged as if we are talking about the arrangement of particles in a liquid. Now, when the particles are disturbed and they start behaving like the way the particles in a liquid behaves, we are going to say we have changed the state from solid to liquid. Now, since we are breaking the bonds that holds the solid particles together, we are calling that bond breaking. And what is causing that is heat, which is going into the solid. That heat is going into the solid, and that now gives us the endothermic. What is that heat going to do? It's going to disturb or break the bonds that holds the solid particles together. And now we call that bond breaking. That's the meaning. So every time when we are using the term endothermic, just know that that is associated to bond breaking. That is very, very important. That is very, very, very important. What are the characteristics of an endothermic reaction or process? Number one, you are going to take note that energy is absorbed from the surrounding. We expect the energy of the surrounding to be decreasing. Why? Because the energy is being taken into the reacting system. Number two, the reactants have less energy than the products. That is an endothermic. Why? Because on the reactants, the energy being absorbed will be used to break the bonds in the reactants. Therefore, the reactants are not going to have energy because that energy is going to be used to break the bonds between them. But in the products, we are going to have bond formation, meaning those products will have greater energy. That's the meaning. That's the reason why when we calculate the energy change, if the reaction is endothermic, the enthalpy change will be always positive. You need to understand one thing. In one chemical reaction, we are going to have both endothermic and exothermic. But what matters is what is going to win. Is the energy change going to be positive? If the energy change is going to be positive, that reaction will be concluded to be an endothermic reaction. What matters is what is dominating. Is our calculation positive? Yes. If the calculation is positive, then the reaction is endothermic. If the calculation is negative, then the reaction is exothermic. That is very, very important. Another characteristic is that the temperature of the system falls. That is very important. Very, very, I say unto you that understand the concepts. We are going to meet energy level diagrams for endothermic reaction. And the interpretation is very important. When the examiner presents the energy profile to you or the energy level diagram to you, how do you know that this reaction or energy level is indicating an endothermic reaction? Look at this drawing. The energy profile, we are going to have the energy increasing upward. And the chemical reaction is progressing in this direction. We are going to have the reactants there, and the products are going to be above the reactants. If that happens, it means here the energy, since the energy is increasing upward, here we are going to have less energy as compared to this level at which the products are being formed, meaning the energy will have greater energy as compared to the reactants here. So when you see the profile is showing the products having more energy as compared to the reactants, it means that reaction is endothermic. Very, very important. You need to understand that. As we are going to practice on how to answer questions on endothermic reactions, I expect you to have basics. At this point in time, I am going to end my video so that you can go through yours village. You compare my explanation to the notes I gave you in class. Take note, understand the concepts. Another important thing, don't forget to subscribe. Remember, revise to be wise, otherwise, no rise. Thank you. Enjoy the lesson. Make sure that you study. You study, you understand, and everything will be okay. Thank you so much. As at now, I say enjoy the rest of your day.